Hello everyone, and welcome to the 8A.5 video number 2. And in the first video, what we ended on was this idea of the rational root theorem, that we list all the possibilities and then we use the calculator to look at the picture and eliminate a lot of these options and go for the top one or two, and then use those options to get synthetic division to reduce this from a higher order degree polynomial to a quadratic, so we could continue to factor down. And as I said before, these two answers were rational because they came written as a fraction, and you also could have answers that are irrational. So if we looked at this next example, find all the zeros, we do have a higher order polynomial, and we want to get this to a quadratic. Because it's a cubic, we're going to have to only do synthetic division one time, but let's find all of our possible rational roots by doing plus or minus p, which is the 44, over q, which is the 13. So all my possible factors of 44 are 1, 2, 3 doesn't go in, 4, 5 doesn't, 6, 7, 8, 9, nope, that's all the small numbers. So then 4 times 11 gives me 44, 2 times 22 gives me 44, and 1 times 44. So all my options for p are already there. My options for 13 for q are just plus or minus 1 and plus or minus 13. So if I divide all the top numbers by 1 and all the top numbers by 13, I'm again going to have 24 different options for all possible real roots or rational zeros. So this is when I'm going to pick up the graph. So if I go to myself already graphing this polynomial on Desmos, I notice that there's only one real answer, and it looks like it's between 1/2 and 1. Now I don't know exactly what this is, so I'm going to go back to my options, and if I look at any of these numbers divided by 1, that's not going to be between 0.5 and 2. So it has to be one of these numbers divided by 13. Let's check this. If I do 1 divided by 13, that's 0.07. That's too small because we want an answer between, we want an answer between 0.5 and 1, according to my graph. Let me look back just in case. Yes, somewhere between 0.5 and 1. So if I take 2 divided by 13, I get 0.15, closer, but not quite. 4 divided by 13 is 0.3, not quite there. 11 divided by 13 is so let's see, 11 divided by 13 is 0.846 and on. If I do 22 divided by 13, my answer is above 1. So this has to be it. This has to be the root that is depicted here on my graph. So this is my one rational root. So what I'm going to do is come back to this slide, and I am going to do synthetic division with 11/13. So I'm going to take 11/13, and I'm going to do synthetic division, recopy all of my lead coefficients so I can get this into a quadratic and can continue factoring. So if I start that process, carry down the 13, 11/13 times 13 over 1, the 13's cross out and I'm left with positive 11. Combine down, I get 0. 11/3 times 0 is 0. Combine down, I get 52. 11/13 times 52 over 1. Well, if I take, how many times does 13 go into 52? Goes in 4 times, so then 11 times 4 gives me 44, which means I do have a remainder of 0, which is nice. And the polynomial that's left over is now a quadratic, 13x squared plus 0x plus 52. And because it's a quadratic, if I set that equal to 0, I can keep solving from there. And just like last time, I am going to go ahead and solve by square roots. So I'm going to get 13x squared equals negative 52. Divide by 13. And if I do that, I would get x squared equals negative 4. And if I take the square root of both sides, I would get x equals imaginary numbers, specifically plus or minus 2i. Now it makes sense that my answers here were imaginary because if I look back at the graph, I only had one time that this graph actually crossed, which means the other two were not real, so they could not actually go on the x-axis. So my answers, by reducing this to a quadratic, my roots written as x-intercepts, are 11/13, 0, 2i, 0, and negative 2i, 0. As mentioned in earlier sections, it is okay to have imaginary answers, and because this was originally a cubic, it said there were 3 possible roots, but 2 of them happen to be imaginary this time. So the rational root test is useful to get all these options, so then when we look at the calculator, we can limit it to the one that makes sense. Now this example, I would like to point out that I think we could have done this by factoring by grouping also. I decided in the video not to do it this way so you could see the rational root test for a second time. But if you do notice on a test or quiz that it could be factoring by grouping instead, please feel free to do so. The last couple of examples are asking us to determine if the binomial, meaning this, is a factor of the polynomial. And a factor, again, means that you have a remainder of 0. So my goal of these problems is to do synthetic division and to see if my remainder does end up being 0, and if it does, that means that this binomial goes into the polynomial or it is a factor. Now to do synthetic division, what you need to think about is if this is a factor, if you solve for x, the actual root is negative 6/8 or reduced negative 3/4. So what we would do is see if negative 3/4, when doing synthetic division, does end up getting me a remainder of 0. So let's see. If I carry down the 8, if I do negative 3/4 times 8 over 1, 1, 2, I'd be left with negative 6. And combining down, I get a negative 56. If I take negative 3/4 times negative 56 over 1, 4 goes into 56 14 times. Negative 3 times negative 14 would be a positive 42. If I combine 42 with negative 26, I would get a positive 16. Then if I multiply negative 3/4 times 16 over 1, 4 goes into 16 4 times. Multiplying would get me a negative 12. Combining down is a negative 8. Last multiplication, negative 3/4 times negative 8 over 1. 4 goes into 8 twice. So that would be negative times negative, a positive 6. So I do get a remainder of 0. So if I get a remainder of 0, that means that it is a factor. If I get anything other than 0, that means I do have a remainder, which means it does not go in evenly, so it is not a factor. This next example, I'm asking the same thing. I'm asking, is this binomial here a factor of the polynomial? So what I'd like you to do is figure out what the actual root is here, if this was true, and then I would like you to do synthetic division and to see if it is a factor or not. So please pause the video now. All right, guys, so here is my work, and I got that 2/5 was a factor of the polynomial, or 5x minus 2 was a factor. I plugged 2/5 in to start the synthetic division. Please check your work to see when you multiplied if you got the same answers as me, and if you combined down if you got the same answers. If you did, you would have gotten a remainder of 0, which meant that 5x minus 2 is a factor. Which also means if I did long division, good times, if I divided this polynomial by 5x minus 2, I would also get a remainder of 0 that way. Okay. So we're going to be practicing this idea in parts A and B, and we're going to be practicing more examples like this one, and especially like this example here, where we had a 4th degree and we had to do synthetic division twice. So please come in with questions in class, and we'll make sure to practice this so you feel more confident. All right, guys, thanks for sticking with me. I look forward to practicing with you soon.